just to write the Cartesian components using the appropriate.
Yeah, so here you have a point charge Q, right? At a point R 0, Z. Express the Cartesian components of the curly R, Rx, Ry, Rz, using spherical coordinates. I think what he means by that curly R, he means the this guy, if I'm not mistaken.
That's the separation.
Yeah, the separation vector. Yeah, so we have here, right? So this is the z-axis, and this is the x-axis, this is the y-axis. So let's just say that the charge is here, right? And let's say, so this is the source, and this is the field point or the observation point. And of course, the separation vector goes from the charge to the observation point. Okay, so this is what we have. And if this angle here is theta prime, right, coming down from the z, and if we project this here, let's use different colors for this. So if we project this, right, so this angle here is phi prime. No? And this here is r. The point is at r away, or r prime. Let's use prime coordinates. Okay. Yeah. So no. Okay. So where's the? Of course, if this is theta prime, this is also theta prime. You agree? Because these two are parallel. And this here is projected, so this angle here is 90 degrees. Okay. Which makes this guy here in red r prime sine theta prime. Okay. So so this point Q is the coordinates will be so let's get the x and the y. Yeah. So this is the here. Let me use this color here and this color. So this here is the x, and again this is a keep in mind that this here is 90 degrees, right? So this x component here will be cosine phi prime, right? Because the hypotenuse is r prime sine theta prime. So Q will have an x component of r prime sine theta prime, comma, cosine phi prime. And what's the y? Sine phi prime, because this is the y here, which is the same thing as this. So this will be r prime sine theta prime sine phi prime, and the z, this is the z. So this is the x, this is the y, and this guy here is the z, which is r prime cosine theta prime. Okay, and
I mean, just write it in to write the components in spherical. So is that what do they mean by not to write it in spherical coordinate basis?
spherical coordinate bases, because I'll show you, because we're going to do the I think they're setting up the stage because they're trying to figure out the electric field of a shell at a distance z away. So so we are trying to write it in the convenient coordinates so we can evaluate the electric field of a shell. See what I mean?
Yeah. Well, like, what's the difference between what would spherical and like it says?
Yeah. So what I'm doing here is I'm writing this in spherical coordinates.
Yeah, but it says spherical basis instead of.
Yeah. So you know the x, the y, and the z. And what would p be now? Yeah. The z component. Yeah. So point P now would be 0, 0, r prime cosine theta prime. And so now your separation vector is equal to what? Now you can form the vector between the 2 points. This was Q and this is P. Right? So that's just r prime sine theta prime cosine phi prime, right? Um, and the second one is 0, 0. So r prime sine theta prime sine phi prime. And the third one will be 0 because you're subtracting them. They're at the same height. Oh, wait. Actually, no, they're not necessarily at the same height. Wait. This here is... no, not at all. Yeah. Well, depending on where P is, he didn't give you a specific location for P. 1 second here. He didn't give you a specific location for in this question for point P. So let me see.
So it makes sense that that R would be equal to P.
P. Oh, actually, he did. Wait, he said at Z. Yeah. So this distance here is Z. Yeah. So it'll be Z minus R prime cosine theta prime. So maybe we should have called that Z prime. Yeah. So this would be the separation vector in x, y, and z, but in spherical coordinates.
Yeah, such as when you're writing out the components. Yeah, I see what that. Yeah, that's right. You're right.